In section 5.3, we're going to talk about double angle formulas and half angle formulas. So in 5.2, we learned about the sum and difference formulas, and so we have two more sets of formulas to do. We'll start with the double angle formula. So first of all, what does that mean? Well, that just is the difference between if theta is 30 degrees, then the double angle would just mean 2 times 30, which is 60 degrees. And so the question is, can you just double the sine? So what is the sine of 30 degrees? Well, I have my unit circle pulled up. The sine of 30 degrees is 1/2. And so the question is the sine of 60 just double that? Is it just 1? Well, no. The answer is no. The sine of 60 degrees is √3/2. So when they say, is it safe to say that you just double the sine when you double the angle? No, it's not just double. There's more to the formula. And so what I have here, if you want to pause the video and write those down on a separate piece of paper, that way you don't have to keep going back in this video. I'm not going to necessarily scroll back up either because I have them written off to the side. So we use these formulas to solve problems like number 1. So it says if sine of theta equals 5/13 and theta lies in quadrant 2, find each of the following: sine of 2 theta, cosine 2 theta, tangent 2 theta. So what I'm not going to do is just take 5/13 and double it and get my answer. That's not how this works. I have to use the formulas. So let's start by drawing this triangle. So they say that theta is in quadrant 2. So I'm going to draw myself a triangle in quadrant 2. So that's theta. And if they give me the sine, then they give me opposite over hypotenuse. And I can use Pythagorean theorem to find the third side. So 5 squared plus b squared equals 13 squared would tell me that b is equal to 12. And so when I label it 12, I just have to be careful about the fact that I am in quadrant 2, which means that I'm going to the left, which means that adjacent side is negative 12. So I'm using an adjacent side of negative 12. So to find the sine of 2 theta, I take 2 times sine of theta times cosine of theta. Well, let's find each of those things. 2 times the sine of theta, well, that's actually given in the problem, or I can look at my picture and do opposite over adjacent 5/13. And then the cosine of theta is adjacent over hypotenuse, so negative 12/13. So what I would do is I would say that 2 is the same thing as 2/1. So I would take all my numerators and multiply them together, and all my denominators and multiply them together. So 2 times 5 is 10, and 10 times negative 12 is negative 120. And then 13 times 1 is just 13 squared, which is 169. So the answer to sine of 2 theta is negative 120/169. And I would want to verify that my fraction can't be reduced. I always want to be on the lookout for that. Cosine of 2 theta is found by taking cosine squared of theta minus sine squared of theta. And so cosine squared of theta literally means take the cosine of theta and square it. So the cosine of this angle is still negative 12/13. And they want me to square that. And then I'm subtracting sine squared. Well, the sine of this angle is 5/13. And they want me to square that. So when I square the first fraction, negative 12 squared is positive 144, and 13 squared is 169, minus 5 squared is 25/169. So then I'm left to take 144 minus 25, and I'm feeling lazy, so 144 minus 25 is 119. So let me give myself some room. My answer is 119/169 for the cosine of 2 theta. And then to find tangent of 2 theta, I can use my formula if I want to, or I can use the fact that tangent of 2 theta is just going to be sine of 2 theta over cosine of 2 theta. Or I can use the formula from above, which is 2 tangent of theta minus, or over 1 minus tangent squared theta. But if I've already done the work to find sine and cosine, let's make my job a little bit easier. I'm going to take negative 120 over 169 divided by or over this 119 over 169, which is the same thing as negative 120 over 169 times 169 over 119. And before you start multiplying, the 169's cancel. So the tangent of 2 theta is negative 120 over 119, which is the same answer that you get if you use this tangent formula, but I'm just using sine over cosine. So to find the answers, notice that sine is negative and tangent is negative and cosine is positive. So what that means is that whatever this angle is, I don't know if it's like 100 degrees or something, when you double that angle, it's not in quadrant 2 anymore. So follow just the problem of whether your answer ended up being positive or negative. Okay, so this practice problem here, let's set up, but I'm actually just going to leave you the answers and you can just verify it in your own time. So they say the sine of theta is 4/5. So I'm going to draw myself theta in quadrant 2 like they tell me, and the opposite over the hypotenuse is 4/5. And if you did Pythagorean theorem, you would find that this third side is 3, and because it's in quadrant 2, it's a negative 3. So I'm just going to write down that for sine of 2 theta, I got negative 24 over 25. For the cosine of 2 theta, I got negative 7 over 25. And then for the tangent of 2 theta, I got positive 24 over 7 because the two negatives canceled out. So if you want to try that in your own time and make sure you get the right answers before you do your homework, you can do that.